Do you remember that time you got on your favorite chat application to send a message to your crush? Or when you were fighting monsters in that popular role-playing game in order to get some gold so you could trade it for an epic sword? Have you ever thought about how the networking might work under the hood? Well, today you'll learn how to create your own chat client and chat server that communicates with one another and also lets you communicate with others. Before we get started, make sure to subscribe to the channel so you do not miss out on any cool update. And if you have any questions, make sure to join the Discord community. Link will be in the description. So the project that we're going to work on today is going to look like this. Before you get discouraged because of the UI look, don't worry, I have a video on how to make a better looking one, which you can see on the screen right now. That being said, let's get into it. So we're going to start by connecting 3 clients. We're going to connect with Armada, Foe, as well as Foobar. There we go. If I start typing something here, hello, we can see that everyone receives that message, but we can type messages left and right. Everything gets sent to the server. If I disconnect with, let's say, Armada, we can see that it disconnected everywhere. This project is so cool, you're gonna love it. So let's pull up Visual Studio and let's get started. All right, so starting up Visual Studio, we want to create a new project. We'll create a WPF application. We can call it Chat App. Now for the target framework, we want to select .NET 5.0, then hit Create. A couple of things before we get started. I like to hit this vertical split in order to have my SAML on the right hand side and my designer on the left hand side. We want to rename this to Chat Client. We also want to add another project by right-clicking the solution, add new project. This is going to be a console application. We'll call this Chat Server .NET 5.0 and create. Perfect. We won't be touching that for now. We're going to be working on the client first. We will be setting this up using an MVVM approach. So we're going to right-click the project. We're going to hit add new folder. We'll call this MVVM. We'll copy paste it a couple of times. This one's going to be called view. Next one's going to be called view model. And the last one's going to be called model. We can group these under the MVVM folder, just like so. Moving our main window into the view folder, that's going to break the application momentarily. Heading into app.saml, we just want to change this to mvvm-view-main window. Rebuild the project by clicking Ctrl-Shift-B, heading over in here. Of course, it didn't rebuild. We're going to start the application. And it works just fine. Closing the main window and opening it back up, reloading the designer, there we go. Now in terms of the design, we want a text box on the left hand side, as well as a connect button, as well as the list where we can see the actual user, somewhere where we can see the messages, as well as an input field so we can actually send messages, and a button to actually send the message. So let's split this grid up into 2 columns. Grid.column definitions. We'll add 2 column definitions. There we go. Perfect. We can explicitly set the width to, I don't know, 200. Is that too much? That's fine. And let's start by adding... Now, for the right-hand side, we want to create a stacked panel. We're actually going to set the column for that one to 1. So the grid column is going to be 1. We're going to add a list view. The height of the list view is going to be about 380. Let's see, 380. Yeah, seems about right. Followed by a text box where the height is going to be 55. Yeah. And the vertical content alignment is going to be center. You know what? Let's actually do this. So instead of having this text box just like this, we'll create another stack panel in here, setting the orientation to horizontal, followed by the text box or let's see, text in box. Setting the height to 55 as usual, the width to about 545, the vertical content alignment to center, obviously. Let's add a button in here, setting the width to 55. There we go. Actually set a content as well. Ooh, content, I can't spell. There we go. Send. All right, and that's the client done, at least the design. Right, so let's try to connect to a server. We need to go ahead and set up the server object first. So let's go into the chat client, add a new folder, call it net. In here, we're going to create a new class, call it server. There we go. Now in the server, we're going to create a we're going to start by creating a constructor. There we go. Inside the class, we want to create a TCP client. Import the namespace, which is using system.net.socket. Call it _client. Inside the constructor, we want to instantiate it to a new instance of the TCP client. So the client equals new TCP client. Perfect. We also want a function that's actually going to connect to the server. So let's do a public void because this will be exposed to the view model. Hence why we're making it public. Connect to server. Perfect. Now we don't want to try to connect to the server if we're already connected. So let's do some quick error handling. If, let's do client.connected, checking, oh, connected. There we go. Checking if it's not already connected. Then we'll do client.connect. Oop, connect. There we go. And we want to connect to 127.0.0.1, which is our local address. And here you want to specify a port. Make sure to pick a port that's not already in use, like port 80. I'm going to go with 7891. That seems like a good port. And that's pretty much it for actually connecting to a server. Now we don't have a server to connect to, so we should probably set up a server. But before we do that, let's just hook up the button on the client so that we can actually, connect to the server. So let's create a view model. So go into the view model folder, call it main view model, create a constructor in here. There we go. Now, since we want to use a command here, we probably want to use a relay command, which I'm going to create a new folder for. So in MVVM, I'm going to create a folder named core. There we go. Inside here, I want to create a new class, call it relay command. Now, I decided to go ahead and write this out, so that you don't have to sit here and look at me write this out. You can pause this right here and just copy this entire class because you will need it. By the way, the source code will be available on my Patreon, which you can find in the description as well. Moving back into our main view model, we're going to create a property of type relay command, import a namespace. We're going to call this connect to server command. There we go. We're also going to create a new instance of a server object, which we created earlier. We'll do a private server, import a namespace, underscore server. In the constructor, we're actually going to do underscore server equals new server. There we go. Clean this up a little bit. And now we want to create a new instance of the command as well. So connect to server command equals new relay command. Object goes into server.connect to server. There we go. And let's go ahead and bind that command real quick. So let's set up the data context for the window. So we'll do window.data context main view model. Oop, there we go. Import XML namespace. And there we go. Let's rebuild this so we can actually see it again. If rebuilding doesn't work, then just close the main view and open it back up. There we go. For some reason, my Visual Studio didn't want to cooperate, so I had to restart Visual Studio in order for this to actually show again. If rebuilding the project doesn't work for you, then just restart Visual Studio and it should work. Right, so the button, let's add a command to it. We do so by adding it as a property, command, binding, and where's the, there we go, connect to server command. Perfect. Now, if we run the application, and we try to connect, it's going to throw an exception. No connection could be made because the target machine actively refused it, meaning that there's nothing listening for an incoming connection on that port, which is good. So let's go ahead and create the server, which is actually going to, accept the connection. So we can close down all of these windows, minimize all these, make it look a little bit better, then heading into the chat server, heading into program, and we can start by creating a TCP listener, call it underscore listener. Let's then create a new instance of the listener. Oh yeah, we gotta make it static because it's in a static context. Static. There we go. We'll do listener. There we go. Equals new TCP listener. We need to chuck in a IP address. We'll do IP address. And we'll call parse 127.0.0.1. For the port, it's going to be the exact same as we specified on the client, which is 7891, in my case at least. Whoops, there we go. Then we'll do listener.start. Now, we could go very in depth with this. We can use like a backlog, for instance. We could do way better error handling, but you got to keep in mind that I'm doing this for people who barely have any idea what networking is. That being said, let's go ahead and accept a client. So we'll do var client equals listener that accept TCP client. There we go. Now this is a blocking call, so we don't need to specify console read line down here in order for the application not to shut down, or well, the server in this case. We can, however, send a message to the console saying client has connected. There we go. Now right clicking the solution, properties, we want to start both of the projects not at the same time. We actually want to start the server first. So I'm going to click the server, move it up in the hierarchy, making sure that it starts first, start, as well as the client right after it. Click apply. Okay. Now I'm going to run the application. Now the server is obviously the console in this case, the client being, well, the client. And this is, look at this. This is really cool. I'm going to click connect. And we can see that the client has connected. That right there to me is so fascinating. Oh yeah, we should probably fix this design here as well. We'll resize that in just a sec. So as of right now, we're only accepting one client, then we're shutting down the server. We want to be able to accept multiple clients and keep track of those clients in some sort of collection. Let's use a list. Let's actually create a custom object for the client as well. So we'll go into the server, add class. We'll call this client. We'll add a constructor. We'll give it some properties such as, well, actually, we'll give it a string property of type name. It could be username as well. Let's do username. Let's give it another property of GUID, which is a globally unique identifier. This is going to be an ID of the application in case we want to specify which client we want to do things with later on. If you want to expand on this, that is. We'll call this UID. We also want to keep track of the actual TCP client socket object in here. So we'll do prop TCP client. There we go. And import a namespace. Whoops. That was, oops. I created a new object. TCP client. There we go. Import a namespace. Call this client socket. Now in the constructor, we actually want to pass in the TCP client. Call it client. We'll set client socket to be client. There we go. We also want to generate a new user ID whenever this client gets instantiated. So we'll do UID equals GUID new GUID to string. There we go. My keyboard does not want to cooperate today. Oh, right. We set it as a GUID, so we're going to have to call toString. There we go. We can then broadcast this into the console saying that a user has connected. So we'll do console write line. We can do, we can actually format this so it looks a bit better. There we go. We'll do it like that, and we'll do date time dot now. Client, client has connected with the username, and then you know we'll format it like this. And we'll do username. Now the username is going to be empty because we haven't read the actual username that the client sends yet. We'll get to that, but for now this will be more than enough. Right, so we have our very basic client object. Let's head back into the program where we define the listener. Let's create a static list of type, so import a namespace as well, of type client, call this underscore users. And underneath, we can actually remove that line. We can do, we gotta instantiate the list as well. So we'll do underscore users equals new collection, which is a list in this case. And we'll do underscore users add. And what we're gonna check in is actually, we're gonna create a new client. There we go. Again with the keyboard. And chuck in the TCP client that this returns. Now that probably went really fast. I'll try breaking it down. So let's just remove that. So we're creating a new instance of the client object that we just created, right? Which takes a parameter in the constructor, a TCP client. This accept TCP client function that we get from the listener actually returns a TCP client. And that's the object we're using as the parameter. Now we can run the application. I can show you the server down here. Connect, and we can see that time and etc, etc. We're not printing out a username because again we're not sending one just yet. We will, but moving on, we actually want to wrap this in a while true loop. There we go. So an infinite loop where we'll be accepting multiple clients, because once we've accepted one client, we want to start processing the packets and whatnot, which is super fun. And then once we're done with that, we want to start accepting the next client. So we'll be able to accept more clients. Let's go ahead and chuck this client that we accepted into the users collection as well. So users.add, and we can chuck in the client. There we go. And down here, we want to later on broadcast the connection to everyone on the server. There we go. So that they can update their local list of users. All right, so I think it's time to actually start sending data to the server. So let's go ahead and head into our client, net, and server. And let's think about this for a second. So connect to server is going to connect to the server. We're going to send the username to the server as well. So we're going to pass that in as a parameter to where we're calling this from. So we'll do string username. There we go. And remember, we're calling this from the main view model, which we can see right here. We're getting an exception because we're not chucking in a username. The username that we want to chuck in, if we look at the main view model, is going to be defined within this text box right here. So we're actually going to create a property in the main view model, call it prop string username. There we go. We're going to chuck this in as a parameter. Right now it's just going to be empty because we need to bind it. So let's do text box, and it's text binding username. There we go. So whatever we pass in here is now going to get bound to this property, which in return is going to be sent over here. Now, the reason to why we want to use a relay command. We want to be able to disable the button if the username property is empty. So if I run the application right now, you can see that I can connect even though the username is empty, that's bad. We don't want that. So we're actually going to add a O goes into string is null or empty, and we'll pass in username. So if the string right here is not null or empty, this command will be allowed to run, aka it's going to make this enabled. So you can see that right now it's disabled, but if I type something in, oh right, we need to set up the two-way data binding. Update source trigger property changed. There we go. Now we can run it. There we go. And if we type something in, we can see that we can now connect. If we remove that, we can't connect anymore. All right. So heading back into the connect to server command, we now have some data that we want to send to the server. But how on earth are we going to do that? This is where the packet builder comes into place. So in our net folder, we're going to create a new folder, call it IO. We're going to add a new class, call it packet builder. All this class is going to do is it's going to allow us to append data to a memory stream, which we'll be able to use in order to get the bytes to send to the server. Because all we're doing is we're just sending the data in the form of bytes from the client to the server and vice versa. So we're going to create a constructor as always. We're going to create a memory stream, import a namespace, call it _ms. In the constructor, we're going to instantiate it to a new memory stream. Let's see, new memory stream. There we go. And we're going to have three functions. We're going to have one that allows us to write an opcode to the packet, which we're going to be able to use as a, essentially as a flag saying, okay, the server is going to be able to interpret the packet different ways depending on the opcode. So if we send a packet with the opcode of 1, we know that the server wants to read let's say a string message, for instance. If that didn't make any sense, don't worry, it will in just a sec. We'll do public void. We'll call it write opcode. There we go. Let's make sure that we spell it a good way as well. There we go. We'll do _ms dot write byte. We'll actually pass in the opcode as a parameter as well. So byte opcode. Oh, not bopcode, but opcode. Opcode. There we go. Now, the reason to why we're writing a byte here for the opcode and not like an int is because we're not going to have 2.1 billion different opcodes. We're going to have less than 255. So in order to make the packet smaller, we don't have to reserve 4 bytes in the buffer. So writing 1 byte to the array, we also want to be able to actually write a string. For instance, the username. So we'll do public void write string. There we go. We'll pass in a string message. There we go. This is going to be a core function because we want to use it to send messages as well and not just the username. We'll do var msg length. So the message length is going to be msg.length. There we go. Because this packet is going to be read as opcode length followed by how many bytes we actually need to read in order to get the full string, which is the payload in this case. We want to do ms.write. There we go. We'll do bit converter. There we go. Get bytes. I want to get the bytes from the message length. So the bytes from this int, which is 4 bytes, we want to get those bytes and append it to the memory stream. Now we want to do the same thing, pretty much the same thing for the actual message. So we'll do ms.write. We'll do encoding ASCII get bytes from the actual message. So now the packet will look like this. We'll have a packet just like that. Opcode is going to be, let's say 1, that's 1 byte. We reserve 4 bytes for the length of the message, which, well, the payload, which is going to be here. Let's say the string that we're sending is hello there. There we go. That's 11 characters if we include the white space. However, if we had a message that's longer than 255 bytes, that wouldn't really fit. That's why we allocate 4 bytes in order to fit bigger messages. So this right here would actually hold the value 11, even though this section right here is 4 bytes big, and we can fit up to 2.1 billion something in 4 bytes, followed by the actual payload right here. All right, and then we want to be able to get a hold of the memory stream, the actual bytes. So we'll do public byte array, because that's what we're going to return, get packet bytes. Oh, I should be able to spell packet. There we go. Here we go. Close that off. And we want to return, return ms.toArray. All right, and that's our entire packet builder done with. You can expand on this later on if you want to. There's also going to be a packet reader, which is essentially a mirror of this. It's going to reflect whatever we're doing here. Heading back into our server, we can create a new instance of that. Well, we can create a member of type packet builder. Let's import a namespace, call it packet builder. Now heading back into the server, we want to create a new instance of the packet builder because this is where we're actually going to start sending the data. So we'll do var, we'll call this connect packet equals new packet builder. There we go. Now remember how we were going to structure the actual packet. We'll do connect packet, write opcode. Now for the actual connection packet, we'll give it an opcode of 0 to keep it simple, followed by connect packet, write string, which is going to be username. And then we just want to send the packet. So we'll do client.client send. All we got to do is connect packet, get packet bytes. And there we go. That's how easy it is to actually send a packet to a server. Let's go ahead and interpret this packet on the server, shall we? So heading into the server, program, and remember where we wanted to actually set the username. That's right here as soon as the client connects. So what we're going to need is we're going to need a packet reader. We can create a folder, call it net, followed by another folder, call it IO. We'll create a class called packet reader. Now this class right here is just going to reflect whatever we're writing. So if we write a string, we want to be able to read it the same way we wrote it. Luckily for most of the operations, we have access to a binary reader. So we can inherit from a binary reader, which already has a lot of predefined functions for reading a bunch of binary data. So we'll create a constructor in here as well. As a parameter, we want to do a network stream rather than a memory stream. We'll call it ns, and then want to pass it into the base class. There we go. We also want to create a private network stream underscore ns. I want to instantiate it in the constructor. So underscore ns equals ns. Now in here, we're just going to have one single function, and it's going to be to read the message. So we'll do public string read message. There we go. We need a temporary buffer. It's going to be byte array message buffer. Var length is going to be read int 32 because that's the size of the actual length that we're sending. Because before calling read message, we've already read the opcode. We haven't done that yet explicitly, but we will get to it. Now the message buffer is going to equal a new byte array with the length of whatever length we just read from the server, the client. Now we'll do ns.read. We want to read into the message buffer. We want to start at the offset of 0. And we want to read the length of the actual packet. Well, the payload. Now we can get the message by var message equals encoding. We gotta import that as well. ASCII get string message buffer. There we go. Oop. Message buffer. There we go. And now we can actually return message as well. And that's how easy it is to read the packet that we just sent. Well, at least reading the payload part of the packet. So heading into the client, this is where we want to read the opcode. We'll do var opcode equals, and we don't have a packet reader in here. We should probably define one. We'll do packet reader. Actually, we can do it in the class. So we'll do packet reader we get an import a namespace, call it underscore packet reader. There we go. We'll instantiate it in the constructor equals new packet reader. And here we need to pass in a network stream. So we'll do client socket dot get stream. That's how easy it is. Now we can do packet reader dot read byte, because that's the opcode. So we can assign this to a variable opcode. There we go. Now, since this is going to be the first packet that we receive and we're following our own protocol at this point, you would want to validate the opcode, check if the opcode is 0, which is what we're sending. If not, then drop the connection. But again, that's out of the scope of this tutorial. We're trying to make this as basic as possible. So let's keep going. Now we'll assign the username equals packet reader read. Was it read string? Read message? No, it's not read string. It's read message. Yeah. Read string is something else. And now if we go ahead and run this real quick, we chuck the server over there. We'll type in a username, for instance, Armada, connect. We can see that client has connected with the username Armada. So we actually managed to send a packet to the server. The server then interpreted that packet correctly and utilized the payload. How cool is that? Right, so we're gonna need a packet reader on the client and we're gonna need a packet builder on the server. So let's go ahead and go into our packet reader. We just copy this over and create a new packet reader in the client. There we go. So remove that, paste that in, import the namespaces. Now I know that this is probably somewhat confusing, understanding like the reading and the writing and why it's got to be on like why it's got to be on both ends. But playing around with this is actually going to make you understand it way better. So I'd say after this, create a couple of chat applications, make one with your friend, make one that you host with a friend, for instance, etc., etc. You'll get it. Now the packet builder, chuck that over on the server as well. So we'll do add class packet builder. So remove this. There we go. Let's do that. Right, now we have the project set up fully to where we can actually send and receive packets just fine. Right, let's start actually working on the fact that where I should be able to connect with multiple clients. And because I'll show you the issue right now. Armada, connect. Right, we connect with Armada, great. We'll connect with Foe, connect. We can see that we actually do connect. We're both connected to the server. However, we're not populating the list. How are we going to do that? The server is actually going to broadcast out a message to everyone connected saying, hey, this person connected, or like, here's everyone that's already connected on the server so you can update your local list. So let's start by doing that. Let's start with the sending of the packet. So we'll head into the server, into program, and right here is where we want to actually broadcast the connection. So we'll create a function, static void broadcast connection. So make sure I spell it right. There we go. All right. We will broadcast a message out saying that a specific client has connected, and we'll pass that client in as a parameter later on. But for now, let's just focus on one thing at a time. We'll do a for each loop. Oh, that's a for loop, for each. There we go. For each, we'll do user in underscore users. Now, for each user that's already connected, we want to send out a packet for each of those users to all the already connected users. That probably made no sense, but it probably will once I actually write the code out. So we'll do another for each loop in here, for each var usr in users. Let's spell that right as well. There we go. And again, there are better ways of doing this. This is just the most readable way of doing it, in my opinion. Taking into consideration that there are people who have no idea what I'm doing. We'll create a new packet because we have a packet builder. So we'll do var broadcast packet equals, let's capitalize TP, equals new packet builder. There we go. Import a namespace. And let's build the actual packet. So we'll do broadcast packet, write opcode. There we go. This opcode is going to be 1. So we're going to interpret this on the client as, well, differently than if we were to send a packet with the opcode of 0. Because the packets obviously do different things. This is how you differentiate each packet. We also want to write a string, which we're going to do here. So write string. No, it's a write message. No, it's actually write string. Yeah. We should probably change that to write message, but yeah, write message. There we go. We'll rename this to write message. And obviously we can't pass in a int. We want to pass in a string, but what is the string we want to pass in? We want to pass in the USR, the current object, dot username. And let's actually pass in the UID as well, which we need to actually cast to a string because it's of type GUID to string. There we go. And then we just send the packet. So we'll do user and not USR. That's very important. Dot client socket dot client dot send, and we'll do broadcast packet get packet bytes. There we go. And where do we want to broadcast this? Right after our connection. So we'll just do that. Perfect. And now on the client, we want to read that packet. Now heading into the actual server on the client, don't get that confused. So in the chat client, the server, we want to create a couple of events. We also want to create a packet reader that we'll be utilizing. So let's go ahead and do that real quick. We'll do a public packet reader. We'll call it packet reader. You can actually capitalize the P because it's a public property. And we don't want to instantiate this in the constructor. We actually want to instantiate it if we manage to make a connection equals new packet reader. And you'll see why. And new packet reader. There we go. Because we want to pass in the client get stream. There we go. Because that's a requirement for this packet reader in order for it to work. There we go. Now that the packet reader is done, we can actually go ahead and create a couple of events. We'll do public event of type action, which is a delegate, which returns nothing. We'll do a connected event. Event. And we'll also do a... Actually, let's start with a connected event. Now heading into the main view model, underneath the server, we can do server dot connected event plus equal in order to attach an event handler. Click tab to generate a new function. We'll call this user connected. And this is what's gonna get invoked whenever, well, we haven't actually told it to invoke anything yet. But that's the function that's gonna get invoked whenever we receive a packet that has the, well, the correct opcode. So heading back into the server, we'll do if string is null or empty, username. So if the string isn't null or empty, we can do that. And then want to start reading the packet. So we'll do read packets. We can call it interpret packets as well, but we'll call it read packets. There we go. In here, we're gonna offload this to a different thread because we don't wanna deadlock the application. We just want to offload the data onto a different thread. The way I'm gonna do it, we're not actually gonna keep track of the thread because again, out of the scope of this tutorial. But let's go ahead and create a new task. So we'll do task.run. Oh, we gotta import a namespace. So there we go. Threading.task. .run. And we'll create a lambda in here. Oh, there we go. And in here, we're gonna have an infinite loop. So we'll do while true. We wanna start by reading the opcode. So we'll do var opcode equals packet reader. We don't have a packet reader in here. We should probably make one. We do have a packet reader. Packet reader dot read opcode, which I thought I had. I can just do read byte otherwise. Read byte works just fine. You could create a function called read opcode as well and just make it return a byte or read a byte from the stream and return that. But you know, this works just fine. And then we'll do a switch based on the opcode. In the default, we can just do constant write line. Ah, yes, of course. We'll do case 1, which is going to be opcode 1. And we're not chucking in case 0 here because, well, we're already handling it somewhere else. So if we get a packet with the opcode of 1, we want to do connected event. If it's not null, invoke. So we're just null checking it with a question mark. This is bare bones of what we're doing. We're going to add more opcodes in just a sec. Let's just finish this one packet first. Then it's going to be the same thing across the entire thing. Right, so in the user connected in the main view model, we want to create a new user. So we should probably create the user model. So let's go ahead into the model, user model, there we go. Let's give it two properties. We'll give it a prop string username, a prop ID, which is going to be a type string as well. We'll call it UID. UID. Perfect. Once user is actually connected, we want to read, because remember how we're sending the username and I guess the UID? I don't know, did we actually send that, or are we're going to? Right, so right here, whenever a user connects, and there's a broadcast, we're sending the username as well as the UID. So in the main view model, we want to create a new user, var user equals new user model. Let's import a namespace. The username is actually the one that we wrote first, yeah, equals server packet reader read message, yeah. And then we want to do the same thing for the UID. UID, perfect. Now we have the user. Now we just want to append it to our collection of users. So we'll do if users. Do we not have users? We don't have a collection of users. Oh, okay. So let's create an observable collection of type user model. So we'll do prop observable collection of type user model. Call it users. Can't even spell it, users. Instantiate it in the constructor. We'll do it at the top. We'll do users equals new user model. Let's go ahead and bind that straight away. So I'm going to close the chat server right there and head into the actual view. This list view right here is going to have the item source binding to users. We need a list view item template. Have a data template of type text block. We'll do text binding and we'll do username. All right. So we'll do, going back into the actual view model, we'll do users.any. You're gonna have to import a link if you haven't already, which is where is it? This one, using system.link. Any, we're gonna pass it as an X, the object as an X. X.uid is equal to user.uid. Now, if the user's collection doesn't contain any user that already has that ID, then we can go ahead and add that to the collection. Now, you would check this on the server as well. Make sure that when the user connects, that it's not like a duplicate user. Now, and in order, since we're doing this from a different thread, we want to use the dispatcher. So we'll do application, import a namespace, which is system.windows.current.dispatcher.invoke. And we want to chuck in the user to the user. So we can actually do users.add, just chuck in the user, just like that. So if we now run the application, I'll chuck the server over here, one instance over here, and then I just chuck another instance down here. We'll connect with Armada, see that the server gets it, and we'll do faux on the other one. There we go. See how we can now see every user. This is so cool. Now, what about disconnecting users or sending messages? We're gonna need two more packets that we're sending, two different opcodes. Let's start by finding out where, actually, let's start by sending messages. I feel like that's gonna be more fun. Right, in order to fix the actual sizing, if you haven't already, I'd set the height to 474 and the width to 816. Now, sending messages is actually really easy. So we're actually going to set up the backend first, and then we'll do the front end stuff. So heading over into the server on the client side, we want to create a function for, we can actually minimize that one for now. We'll create a function, a public void send a message to server. String message is obviously going to be a parameter. And we can just build a packet and send it straight away. So the var connection, no, what am I saying? Not connection packet, message packet equals new. And we'll do packet builder, the connection pack, or I mean the message packet, write, no, it's message packet, there we go, dot write string, we write message, we should change that name, write message, there we go. Write message is going to be message, but we also need to add an opcode prior to this, so we'll do write opcode, and we're going to add the opcode of 5. 5 is going to be the opcode that defines sending a message, and this can be any type of message, and then we just send it. So we'll do client.client.send, and we'll do message packet dot get packet bytes. There we go. Now we just need to call upon this whenever we click the send button on the view. So heading back into the view model, we also want a property for the message. So we'll do, instead of username, we'll create a new property, call it message, which we're going to bind in the view. There we go. It's going to be bound in here. So we'll do text binding message. And we don't need to specify the update source property trigger, because whenever we click the send button, it's going to lose focus. And whenever it loses focus, that's when the property updates. So let's create a command. We'll do send message command. And we'll create a new instance of it down here, send message command. It's going to be equal to, well, actually, it's going to be the same condition here to when you can and cannot send it. But instead of username, it's going to be message. Here we go, button, command. Binding send message command, which is going to be disabled to begin with. And yeah, we're going to have to do the update source property trigger. Update source trigger, it's going to be property changed. And now if we type something in, it's going to work. Heck yeah. What we can do is we can actually do send message to server and then do message, rather than creating a something over here that actually sends it, because that would be kind of redundant in my opinion. So let's go ahead and call that just like so. Now, since we're sending this to the server, we need to interpret it on the server as well. So let's head back into the server. Let's go into program, and from here we want to head into client, and we want to set up a processor in here, which is going to process all the packets that we get. So we'll do void process. We'll do a while true, because it's going to be running forever until we break out of it, being that if something disconnects or if something goes wrong. And we'll do a try catch. The exception here, you can specify a network exception if you want to. Again, out of the scope of this tutorial. We'll do, so we want to keep reading bytes. Essentially, we want to keep reading packets. So we're essentially going to do the same thing we did earlier, where we had the events, but we're not going to use events here. Even though you could, but we won't, because we're only going to be interpreting one packet. So we'll do var opcode equals packet reader dot read byte. There we go. That's going to be the opcode. We'll do a switch statement based on the opcode. We'll do case 5 because that's the opcode that we're sending. Remember how we structured it? We just got to read it the same way. So we'll do var message equals packet reader read message. We can write out the message. Message, we'll actually structure it a bit nicely. Here we go. We'll do time dot, oh, do it isn't, oh, it's date time. Yeah, of course. Date time dot time. Maybe now. That's the one. Followed by message received. And so we'll just do print out the message as well. And then we want to broadcast the message. Broadcasting the message is super simple. We'll head into the program. We have a broadcast connection, which we should probably spell correctly. Broadcast connection. There we go. And now we want to have a function that broadcasts the message. Public static void broadcast connect. No, broadcast message. There we go. And we might as well pass in the parameters with a string message. And then we want to send it out to every user. So every user in users. There we go. And then we just, for each user, we want to construct a packet and send it out. So we'll do var message packet equals new packet builder. And we'll do message packet, write opcode. And this is going to be 5. And we want to write a string, so write message. It's obviously going to be message. And then just user dot client socket dot client dot send. And then message packet dot get packet bytes. Now going back into the client.cs, we want to call that function. So we'll do program dot broadcast message, and we'll pass in message as the parameter. Now, while we're here, we might as well deal with disconnect. So if we try to process something and we get an exception, it's usually because of the fact that we can't, read the data because the connection was closed or something. That way we want to broadcast a disconnect packet as well. So we'll start by printing out which client is connected. Again, you should probably error check this a bit better if you're planning on using this in production. We'll do UID toString, which I don't think, we don't need toString. It's gonna print it out anyways. Let's do disconnected. There we go. And then we'll do client socket dot, we'll do close because that's gonna dispose of the actual object as well, and then close it. Now we probably want to broadcast a disconnect packet as well. So we can actually create one. We can copy this one and just change the name of it. We'll do disconnect message, or actually we'll call it broadcast disconnect. And we want to find the user that did disconnect based on the UID. So we'll do UID, and we can actually remove that. We'll call this broadcast packet. I want to find the user, as I said. So we'll do var disconnected user equals, I'll do users where, I need to import link, where x, the UID is the same as UID. Let's get the first, oh right, we need to cast it as a string, there we go. And we want to get the first or default value. Default's going to return to null. However, we want to remove that, users, remove, and we want to remove the user that was disconnected, so disconnected users. Now we won't have an issue sending a packet to every user in the users collection because the one that was disconnected and can't be sent to anymore is now gone. So we'll do broadcast packet, write opcode. Now the opcode for a user that was disconnected is going to be 10. The data that we want to send is the user ID of the person that was disconnected. So we'll do write message, it's going to be UID, and then we just got to send it. So the user dot client socket dot client dot send, and we'll do broadcast packet get packet bytes. There we go. And what's cool now is that since we can broadcast a message to every person on everyone connected, we can just call broadcast message afterwards saying that the user disconnected. We'll check in the name like so. So we'll get the disconnected user, that username disconnected. Perfect. So now every client's going to be able to see that. Right. So now we need to head into the server on the client and let's see, read packets. Now we got to interpret 2 more packets. So we got to do case 5 and case 10. So we'll do case 5 followed by case 10. And the events that we want to invoke is not the connected event, obviously. We want 2 new events. We'll do message received event as well as disconnect. We'll do user disconnect event. Amazing. And obviously it's going to be message received on 5 and user disconnected on 10. Looking good so far. Now in the main view model, we want to hook these up as well. So we'll do message received. We also want to do user disconnected. For this one, we're going to create a new function, which is going to be called message received. we're gonna create a method. There we go. And in here, we want to just read the data that we got sent. So the var message equals server dot packet reader, which is a public property, read message. And then we just want to add that to our messages collection, which we don't even have yet. But we can create one by doing it like that. We'll do messages. It's going to be an observable collection of type string. This one is going to be instantiated in the constructor as well. Messages, there we go. A new observable collection of type string, which we're going to hook up in the main window as well. The messages are going to be displayed in the list view. So the only right thing to do would be setting the item source, binding it to messages. There we go. And now we just need to append that to the messages collection. So we can do application.current, current.dispatcher.invoke, an anonymous function, also known as a lambda, messages.add, messages.add, and then the message. Oops, there we go. All right, and for the actual disconnecting of a user, we just want to remove them from the collection. So we'll create a user disconnect. We'll call this remove user. We'll create a new method, just like that. We need to get the UID first. So var UID equals server packet reader read message, which is the first thing that we send whenever we get, or whenever we do send the disconnect packet. The first thing we do send is the user ID, followed by the username. Actually, no, that's the only thing we send, isn't it? Yes. So we're gonna try to find the user based on that ID. So we'll do users where x.uid is equal to the UID that we got. First or default. First or default. There we go. And then we can just remove this user from the collection. So we'll do application.current.dispatcher.invoke, and we'll do users remove, and we'll get the user in there. All right. Now let's go ahead and do the, did we bind the send message command? I think we did, didn't we? Right, send message command, which sends a message to the server. Now, as of right now, we need to head back into the actual server, go into the client, and start the processing, because we haven't started the actual process function. So we're gonna do that right underneath here, but we're gonna offload that to a different thread, so we don't, get caught up on the while loop. So we'll do task.run, and we'll chuck in the process right there. And another thing we want to do is we actually want to get rid of this throw statement down here, as well as we want to broadcast the the disconnect. So we'll do program.broadcast disconnect, and we want to pass in the UID to string. There we go. And then we want to break out of this loop. All right, and I believe that's it. We can actually make things look better. For instance, when we broadcast a message, we can let's see. So in here we can actually give the date and the username. So we could do something like we'll do something like that, and we'll say date time dot now, followed by username, followed by the actual message as well. So we'll chuck that in there. All right, let's try running this real quick. I'm gonna chuck the server over here and the client there. I'm gonna pull up another client. There we go. We'll pull up a third one as well, because why not? There we go. We'll do foo, we'll do armada, and we'll do foo bar. Why not? If I send a message right there, we can see that foo sent that message. Armada hello, send, and well, this one as well, obviously. Now, if I were to disconnect with Armada, we can see it disconnected, it removed it from the collection. This is so cool to me. I don't know why. And that pretty much sums up the actual project. Now, as for all my projects, this is not something that you probably should use in any sort of production environment at all. This is more so to show you how to create something and the actual concept of it. There are things that you probably want to error handle and various other things, but that pretty much sums it up. The source code for this project will be available on my Patreon, which you can find in the description down below. If you enjoyed the video, make sure to leave a like and subscribe. And as always, I'll see you in the next one.